Hello everyone, welcome to another video of Cloud Deep Dive. In today's video, we will talk about Private NAT Gateway, a new feature launched by AWS recently. Before we jump into learning about Private NAT Gateway and what use cases it will solve, let's first try to understand what is NAT Gateway, why it was invented, and how it is used in today's world. So if we talk about your home, at your home you have many appliances and computers, laptops, your TV, your refrigerator, your other appliances which might require a connectivity with the internet. And you know that to connect any appliance or anything with the internet, you require a IPv4 address, public IPv4 address. Suppose you have 15 different appliances sitting at your home and require a connectivity to the internet, you will need to provide a 15 different public IP addresses to those appliances or to those laptops or whatever you have to or need to be connected to the internet. And similarly, every home will have so many appliances or these uh, computers which need to be connected to the internet. If we start assigning IPv4 address, public IPv4 address to all these appliances, we will run out of those IPv4 address because IPv4 address space is very limited. Now to solve that problem, NAT was introduced. NAT is Network Address Translation. How it works then? You have multiple appliances sitting in your home which is connected to the router which is talking to the internet. Now within the router there is a NAT device configured, and what it does that whenever a request comes from these appliances, they don't have any public IP addresses, they will be sent to the router. Now the NAT device will activate here and it will have a public IP address assigned to it. Now it will convert or it will send the request to the internet by giving its own IP address, its own public IP address. So all your appliances are private to you. They are not exposed to the internet. Only the IP address of your NAT gateway or the NAT appliance will be communicated or it will be communicating with the internet. Similarly, when the response will come, it will come to the NAT appliance IP address and then the response will be sent back to your appliances. So that's how NAT work in between. It translates all the requests coming from your private appliances to it, adds IP address, send it to the internet, gets the response and send it back to your appliances. Now, if we talk about in the cloud, uh, first we used to have NAT instances and then the NAT gateway was introduced and uh, both work in the same way. The only difference is NAT appliances were single point of failure because you have those appliances in the public subnet, and if that particular instance fail, then your whole connection will block. So to solve that, AWS comes up with the NAT gateway, which is highly scalable. It's managed by AWS, and the way it works that if you have a private subnet where one of your appliances is sitting in there and it needs a connectivity to the internet, and when I say connectivity, suppose it need to download some security patch or any other updates, so it will need to connect to the internet. So instead of providing a direct internet connectivity to these EC2 instances or your database servers, what we do, we create a new public subnet where we create NAT gateway and we set up the route table in such a way that any internet traffic going from your private subnet will go to your NAT gateway, and in the NAT gateway subnet we say that any traffic going to the internet will go to the internet gateway. So anything, any request going for the download of your security patch or any other update, it will go to the NAT gateway. NAT gateway will connect to the internet via internet gateway and get the data back and provide it here. But if anyone, because this EC2 or RDS or any database, whatever server you have in there, they don't have any public IP address. So if somebody want to try to connect from the internet, they don't have its public IP address because it's not assigned and they cannot connect to the private IP address. The only IP address they are getting for this NAT gateway. So that's how NAT gateway solves the problem of connecting where private uh, subnet instances or database or servers need to connect to the internet or for any updates or any security patch update, they can use a NAT gateway. So one of the dependency of the NAT gateway was the internet gateway. If you don't have any internet gateway assigned or associated with your VPC, your NAT gateway deployment will fail. And another thing for the NAT gateway was you have to have an EIP or a IP public IP address assigned to it, which it can use to connect to the internet. Now, question comes that why we need the private IP address when we had a public NAT gateway. So the difference between the public and the private NAT gateway was that public NAT gateway is have a dependency on internet gateway, but private NAT gateway does not have any dependency on the internet gateway. That means that if you create a private NAT gateway, the internet gateway doesn't need to be associated with your VPC. You can still create an ad gateway without having an internet gateway attached to your VPC. Second, you don't need to assign a public IP address to a private NAT gateway. That's another difference. So these are the two key differences between public NAT gateway and the private NAT gateway. Now the question comes that so far, whenever we are learning with an ad gateway till now, if for any exam or anyone is teaching, we always say that NAT gateway is used to connect to the internet for your private subnets, and it connects to the internet by using your internet gateway. If I remove the internet gateway from there, if the dependency is not there, then what type of use cases your private NAT gateway is gonna solve? Yeah, so that's we're gonna talk in our next few slides. But before that, I just want to show you that how you can configure a private NAT gateway on the console. And I also want to show you that if you try to create a public NAT gateway without having an internet gateway, it will fail. So let's go to our console and we'll see how it works. So guys, I've logged into my console, and I have a VPC in North Virginia region. If I go to internet gateway, you can see that it's detached, it's not attached to my VPC. And when I go to NAT gateway and try to create a NAT gateway, suppose I say test one, and I can create in any of the subnet, and I want to do it connectivity type is public. I'll assign it EIP because that is required for the public subnets, sorry, public NAT gateway, and let's do create NAT gateway. Right now it's in pending state. It will take around 1 to 2 minutes, and after that you will see a state message here saying that let me show you what I tried earlier which failed actually. So you will get a state message network VPC has no internet gateway attached, and it is gonna fail in some time. So it will take around a minute or 2 minutes, and after that it's gonna fail. So I'll let it run, and once it fail I'll come back to it. In the meantime, let's go and check how you can create a private NAT gateway. So similarly on the NAT gateway, we'll go to the same screen and say private NAT, whatever name you want to give it, and you choose a subnet. Suppose I choose the same subnet, and the connectivity type you will say is private. So you can see that the moment I did the private, the EIP field is gone. So for the public subnet, you need to provide elastic IP address, but for private, you don't need to. And let's click on create NAT gateway. So it will take a few minutes. So I'll do one thing, I'll pause that video, and then we'll come back once the public one which we created is failed, and private one which we created will pass, and we will be able to connect to it. Okay guys, so as you can see, the public NAT gateway which we created is failed with the address with the state message of that network VPC. VPC name has no network or internet gateway attached, and the private one which we created is available. It created successfully. So that's the one of the dependencies. Wanted to show that whenever you create a public NAT gateway, it had a dependency of that your internet gateway should be attached. Otherwise, it won't allow you to create a public NAT gateway. So guys, as you saw that you can create an NAT gateway without assigning any elastic IP address or any internet gateway, which makes your VPC totally private VPC. So now let's talk about few use cases which your NAT gateway can help you out to achieve. So one is like with the growing industry and lot of acquisitions are going on, one company is acquiring the another one, and even the same company is expanding. A lot of teams are working in parallel. They end up in a situation where they have two VPC with the overlapping societal law, and they always come with a challenge that we want to connect these two VPC with each other. They should be talking to each other, but we want to keep that communication as private. So how an ad gateway will help you out to solve that particular use case. So if we see to solve that, what we can do, we can create a new private subnet in that particular VPC, and we can give a different IP address range. Like in this case, I gave it 200.0.1.0/24. And in other VPC as well, we can give a private subnet of 200.0.2.0/24. And what we'll do, we'll create a private subnet or private NAT in this private subnet, and we'll connect these two VPC by using a transit gateway. The one key is that don't enable the route propagation, otherwise all the routes will be propagated. But what we'll do, we'll manually configure the routes in this transit gateway. What we are going to say that if there is any traffic for this private subnet, then send it via this attachment. And if there is any traffic for this particular subnet IP range, then send it or route it to this VPC attachment. Another thing what we are going to do, that similarly we do for the another NAT gateway, that this EC2 instance need to talk to this EC2 instance, or maybe there are multiple EC2 instances are sitting in this particular subnet. What we will do, that we will put all these EC2 instances behind a load balancer, and instead of directly communicating to these EC2 instances, we will communicate via this load balancer. So what we will say, that if there is any request or any traffic for this particular IP address range, send it to NAT gateway, and in the NAT gateway subnet, we'll send the same CIDR range traffic to the VPC attachment. Transit gateway. And once this go to transit gateway, it will send it to the VPC attachment, which reach to your load balancer, and the load balancer will send the traffic to your EC2 instance. So by using this architecture, the private NAT gateway, without having any internet gateway or without assigning any elastic IP address, we can keep the whole traffic private, and we can solve the problem where two CIDR ranges are overlapping with each other. So this is one of the use case which your private NAT gateway will solve or will help you to solve this. So guys, in this scenario, we talked about only two VPC having same CIDR. But with the growing industry, new and new projects are coming in a company, and each team will deploy their own VPC, and they might end up having the same CIDR range. And this problem will happen for those particular VPCs as well. So if you have multiple VPCs in your company having this kind of issue where CIDRs are overlapping with each other and you need to create the connectivity, then it can be a big mess. So one of the solutions which you can use to avoid the situation or to help you out to so that those VPCs can talk to each other, that you can have two different CIDR ranges. One is routable, one is non-routable. When I say routable, you can create one CIDR range. Like in this, I have 200.0.1.0/24. This is my routable because I can add a route in the transit gateway that traffic coming for this one will route somewhere. So we can have a big range of routable IP addresses, and another like RFC the 1918 one, like 10 dot or 172 dot or 192 dot, we can keep it as non-routable. So any VPC is created will be created with the non-routable IP addresses, and then the secondary CIDR will be added to that VPC for the routable range. And instead of 24, we can just keep it 28 as well, or whatever number of IP addresses we require for that subnet to route the traffic. And by using that feature, you can have one routable subnet with that secondary range in all your VPC, which you can use to connect your either virtual private gateway or transit gateway to route the messages between the VPC, and the other non-routable will be your you can have all other subnets in the VPC with a non-routable, which you don't want to communicate or which you don't want to expose to anyone else, and all the communication you can keep through your routable IP address. So that's it for today's video, guys, on private NAT gateway. Please let me know if you have any question by putting a comment. Please do subscribe to our channel and press on the bell icon so that you get notified for our newly launched videos. And please do like and share with your friends. Thank you so much, guys.